Hello everyone. In this video, I will discuss number system. So this is the number system, real numbers and imaginary numbers. If we combine real numbers and imaginary numbers, that defines your complex numbers. So we will discuss these components of real numbers and the imaginary numbers, and lastly, the combination of real and imaginary, which is your complex numbers. To start off, natural numbers or n are part of the number system, which includes all the positive integers from 1 till infinity. So natural numbers is also called as counting numbers. So this is the symbol representation of natural numbers n. So the elements of natural numbers n consist of series of sets of 1, 2, 3, 4, 5, 6, and so on and so forth. So it starts with 1 until 2 until infinity. So the next is whole numbers, represented as variable w. Whole numbers are number without fractions, and it is a collection of positive integers and zero. So w is equal to a set of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. So in short, 0 plus natural numbers or counting numbers, that defines your whole numbers. So if it is in the number line, so from 0, 1 up to infinite positive. Next, integers represented as variable z. Integers are the set of real numbers consisting of the natural numbers, their additive inverses, and zero. It is also the set of numbers containing whole numbers and their opposites. So when you say additive inverses, so for example, 5. So the additive inverse of 5 is negative 5. So that is additive inverses. So integers is consists of whole numbers plus additive inverses or additive inverse of the number. That is integers. So if we refer to a number line, integers include 0, negative integers, and positive numbers. So take note that integers can either be positive, which is located at the positive, or the positive number is located at the right side of the number line. So this is the positive. And the negative integers is located at the left side of the number line, which is or which has a negative sign. And between the two positive and the negative, that is 0. Next is rational numbers. Rational numbers are set of numbers which can be expressed in the form of A over B, where A and B are integers and B should not be equal to 0. Why? If B is 0, the number or it makes the number undefined. So these are the list of rational numbers. So 0, it is also a natural numbers. Then whole numbers, integers, and fractions. So fractions in A over B can be expressed. So for example, 4 over 8. So that is a rational numbers. 2/5 is also a rational numbers. Rational numbers is also a terminating decimal. Terminating decimal. When you say terminating decimals, it is a fraction that once you change or convert into decimal, it terminates to a certain value. For example, 0.75. 0.75 in fraction, that is 3/4. So it terminates to a value. Once you divide or once you simplify the decimal and it terminates to a certain value, that is rational numbers. Rational numbers is also a repeating decimal. When we say repeating decimal, the decimal repeats to a value. For example, 0.333. 0.333 in fraction is 1/3. So it repeats to a number 3333 and so on and so forth. So that define as your or that define as a rational number. So again, rational number is a terminating decimal and that is also repeating decimal. Next, irrational numbers. When we say irrational numbers, it is a real number that cannot be written as a simple fraction. So this is the other way of rational. This time, irrational cannot be written as a simple fraction. So these are the famous irrational numbers. The pi, which is a famous irrational numbers. People have calculated pi to over a quadrillion decimal. So 3.1415926 and more quadrillion. And then another example of irrational is E. That is a number E, Euler's number. It is another famous irrational numbers. People have also calculated E to a lots of decimal places. So the certain value of E is 2.71828182845 and so on and so forth or and more. And another example is the golden ratio, which is also an irrational number. So the value of golden ratio is 1.618 and more. Also, if it is involved in radicals, so for example, square root of 3, the value of square root of 3 is 1.73205080 and so on and so forth. Square root of 99, 9.9498 and so on and so forth. That is irrational numbers. But remember, not all numbers enclosed in a radical is irrational. For example, square root of 100. Square root of 100 involves radical, but square root of 100 can be simplified into 10. So 10 is a counting numbers. So that is also a rational number. So square root of 100 is a rational, not a irrational numbers. So that is why example here is square root of 4. That is not an irrational, that is rational. And square root of 9 is 3. So that is a rational. So if it is included in the board exam, check. If it is involved in radical, before you conclude that is rational or irrational, check first if the radical can be simplified. If yes, then that is rational. If it is cannot be simplified, then that is irrational numbers. Next is transcendental number. Transcendental number is a real number that is not the solution of any single variable polynomial equation whose coefficients are all integers all transcendental numbers are irrational numbers. So these are the list or example of transcendental, the pi, and then the e. So transcendental numbers have no pattern and are non-recurring or non-repeating and non-terminating. Number system, another is complex. Complex number is a quantity of the form a plus bi, where a and b are real numbers and I represents the unit imaginary. So this is the representation of a complex number, a plus bi. A and b are real numbers. So a is the real component and b is the imaginary component of the complex number, where I is the imaginary unit and I is equal to square root of negative 1. For example, 8 plus 12i. So 8 is the real component of the complex number and 12 is the imaginary part or component of the complex number. Now, what is imaginary number? Imaginary number is a complex number that can be written as a real number multiplied by the imaginary unit I, which is defined by its property. I squared is equal to negative 1. So square root of negative 1 is always equal to I. Every time that you have a negative inside the radical, so you change that into positive and then you take out I. For example, square root of negative 25. Square root of negative 25 will be changed into positive, but you put I outside. That is square root of 25 times I. But square root of 25 can be simplified to 5. So 5 times I, which is your square root of negative 1, that is 5i. Likewise, in square root of negative 16, that is square root of 16 times I. But square root of 16 can be simplified into 4, 4i. Then square root of negative 10, that is square root of 10 I. So square root of 10 can no longer be simplified. So it retains to I square root of 10 or square root of 10 I. Then square root of negative 32, that is square root of 32 I. Square root of 32 can be simplified to 16 times 2 and square root of 16 is 4 times I 4i. But square root of 2 cannot be square root, so it will remain to the square root or inside the square root. That is 4i square root of 2. Now, these are the set of all numbers. As you have noticed, the one that is in blue colors is the composition of a rational, or I mean the composition of real numbers. Real numbers is consists of rational, integers, whole numbers, rational or natural numbers, and prime numbers and composite. So we already discussed what is prime numbers and composite numbers in our module 3. So that is your natural numbers. So combining the real plus imaginary numbers, that is your complex numbers. So complex number has a real component and imaginary component. That defines your complex number. So this is the set of all numbers. So these are my references of this video. And that would be the end of my discussion. Thank you and hopefully you learned something. Salamat.